Far above you, past the reach of mountains and the thin shimmer of clouds, a fleet of quiet guardians circles the Earth. They are not alive, yet they keep watch over your movements. They do not sleep, yet they mark the passing of seconds with tireless precision. These are the satellites, the clockwork above, and they hold a secret about time. You cannot hear them, but they are speaking to you right now. In your phone, in your car, in the gentle guidance that tells you which street to turn on or how far the forest trail will carry you. Their voices arrive. Each one sends a timestamp, a pure signal, a pulse in the void. Your device listens to several at once, and from the differences in their messages, it knows where you are on the surface of the spinning world. It seems simple. A machine in the sky says, "This is the time." Another says, "This is the time." Your device compares the two and draws a map around you. But if these satellites ran on the same time your own clocks keep here on Earth, the map would be wrong, wildly wrong. Within minutes, you could be misplaced by miles. The problem is not in the machinery. It is in time itself. A satellite's orbit is high, far from Earth's surface. It moves quickly, thousands of kilometers per hour. And here, Einstein's relativity begins to whisper its influence. Two effects shape the ticking of its clock. One comes from motion. Moving fast makes time slow down, as seen from the perspective of someone standing still. The other comes from gravity. Being farther from Earth's mass means gravity's pull is weaker, and in weaker gravity, time speeds up. You might picture the satellite's clock as a delicate balance on a scale. On one side, speed presses downward, slowing the ticks. On the other, reduced gravity lifts upward, quickening them. But the two are not equal. The gravitational effect is stronger. The net result, the clock in the sky ticks a little faster than yours. It is a tiny difference, about 38 microseconds faster each day. A microsecond is a millionth of a second. But in the mathematics of positioning, even this sliver of time matters. Light, which carries the satellite signals, moves at nearly 300,000 kilometers per second. In a single microsecond, it can travel hundreds of meters. A drift of 38 microseconds in a day would send your GPS position adrift by thousands of meters. You would be told you are in the middle of the river when you stand in your kitchen. To prevent this, engineers bake Einstein's insight into every satellite's design. Before launch, they adjust the satellite clocks so that once they are in orbit, affected by both speed and gravity, they run at exactly the rate we expect here on Earth. Without this correction, the GPS system, the invisible net that catches you in space and time, would tear within hours. It is a strange truth. You cannot find your way home without first bowing to the bending of time. If you were to float beside one of these satellites, matching its speed, you would find nothing unusual about its clock. To you, seconds would pass in the same way they do now. Your heartbeat would not stretch or shrink. A conversation, a laugh, a sigh, all would feel normal. But the moment you compared your clock to one on the ground, you would see the drift. And in that drift, you would feel the pull of the universe's quiet rules. You might imagine each satellite as a bead on an invisible necklace strung around Earth. The string is gravity, the bead is the machine, and the space between beads is filled with silence. From the ground, they move in slow, graceful arcs, crossing the sky in hours. From their own vantage point, the Earth turns beneath them like a giant globe turning in a darkened room. Even while you sleep, they are awake, drawing invisible lines between themselves and you. Even while you sleep, they are awake, drawing invisible lines between themselves and you. In the stillness of night, your position is known to within a few meters because high above, clocks in a different rhythm keep perfect watch. Time in orbit is not better or worse than time on Earth. It is simply different, flavored by the conditions in which it is kept. Like honey thickening in the cold or melting into warmth, seconds stretch or contract depending on where they are. It's not only GPS satellites that feel this shift. Any clock in motion or in a different gravitational field will keep time at its own pace. Astronauts aboard the International Space Station, though much closer to Earth than GPS satellites, still move fast enough that time bends for them too. When they return after months in orbit, they are a fraction of a second younger than they would have been had they stayed on the ground. Fractions of a second may seem trivial until you realize they are cumulative. Over cosmic distances and speeds, they grow into hours, years, centuries. They are why we can speak seriously of traveling into the future by moving quickly enough or falling deep into gravity's embrace. You hold a piece of this truth in your pocket every day. When you check a map on your phone, you are not just seeing roads and rivers. You are seeing the product of a cosmic compromise, the reconciliation of time on Earth with time in the sky. The satellites are impartial. They do not choose to help or hinder you. They simply exist, following the rules that space-time lays before them. They are like lighthouses, their beams invisible to the eye but constant, steady, unwavering. And yet, those beams carry a truth stranger than any ocean's horizon, that now is not the same everywhere and never will be. Perhaps this is why their presence feels comforting. High above, beyond the turbulence of weather and the restlessness of human life, they move in serene, predictable paths. They obey a dance choreographed not by human hands, but by the curvature of space-time itself. To watch them, if you could, would be to see the universe keeping time in its own language. And you, here on Earth, are part of that language. Your days and nights are written into the same script as those distant machines. Your steps are measured against their orbits. Your location is woven from the strands of their timing. In their quiet precision, they remind you that you too are bound by the same laws, moving through the same slow tide of moments. One day, perhaps, you might look up and feel a kind of kinship, not with the machines themselves, but with the way they are suspended between worlds. Neither fully in the pull of Earth nor free of it. Neither moving through time as you do, nor entirely separate from it. Above you, the clockwork continues, each satellite a careful note in a song without end. And as you listen, even without knowing, you are carried by its rhythm. It is the rhythm that will guide you across seas, through forests, back to your own front door. It is the rhythm that will remind you. Time is not fixed, not single, but many-layered, shaped by where you are and how you move. You close your eyes, and still the satellites keep watch. Their signals thread through the darkness, each one a bridge between worlds. And in their patient arcs, they point toward another truth, a truth about limits, about the highest speed the universe allows, and the way light itself holds all our clocks together. You are made of time. Every heartbeat is a drumbeat in its river. Every breath is a small tide, pulling in and letting go. Your cells move through their own quiet cycles, dividing, repairing, pausing, a choreography they have followed for billions of years. It feels steady to you. It feels like a clock that never wavers. But your clock is not perfect, not because it is broken, but because time itself is not the same everywhere. It bends and curves and stretches around you, so gently you never notice. Your body moves inside this invisible fabric, always carrying the mark of where you've been, how fast you've gone, and how deep you've sat in gravity's pull. Think of your atoms, the smallest pieces that still hold the identity of you. They vibrate with energy, their electrons tracing tiny orbits of probability. This vibration is one way to tell time. If the rhythm changed, even by a fraction, the chemistry of life would change too. And yet, if you were to live on a speeding spacecraft or deep inside a valley carved by gravity's weight, those rhythms would quietly shift. To you, they would feel the same. To an observer far away, your body's clock would be moving differently. It is not only atoms. Your heart itself keeps time. Not like a metronome, perfectly fixed, but like a living musician, adapting to the music of your moments. The pace changes as you run, as you rest, as you dream. But under all that, it is also answering to relativity's gentle rules. In motion, your heart's beat, as measured by someone watching from a place of stillness, would slow. Not because you are unwell, but because time itself has lengthened for you. Even your dreams are bound to this. Imagine sleeping on a ship traveling near the speed of light. Inside your cabin, you feel no strangeness. Your eyes close, your breathing deepens, your mind begins its slow drift into images and stories. But to the outside world, your dream lasts longer than they expect. It is as though you are walking through honeyed time, every step slowed by the way the universe holds you. The principle is simple, though the feeling is subtle. The faster you move, or the farther you are from a strong pull of gravity, the quicker your clock runs compared to one on Earth's surface. The slower you move, or the deeper you are in gravity's grip, the slower your clock runs compared to one far away. This is not a trick of machines. It is not a quirk of measurement. It is a real, physical truth, woven into the way space and time are connected. You might wonder, if your body's time changes, would you feel it? The answer is, almost never. Inside your own frame of reference, your seconds are always the same length. Your heartbeat still fits the same number of moments between one breath and the next. You only notice the difference when you compare it to someone else's clock, and they are not beside you. Imagine two identical seeds planted in two identical pots. One is set on a table, the other on a swiftly moving train. Each seed feels the same sun, the same soil, the same gentle hand watering it. Each grows at what it feels is its normal pace. But when you bring them back together, you discover that one is slightly younger than the other. They have not shared the same path through time. This is the quiet truth of your own body. Your cells are a forest of countless tiny processes, each one a clock of its own. When you walk, when you travel, when you live at a certain altitude, those clocks subtly adjust to the space-time you inhabit. It is a symphony constantly being retuned, softly, invisibly. Gravity's influence is perhaps the most intimate. Here on Earth's surface, you are held tightly in its embrace. If you were to live for years on a high mountain, where gravity's pull is just a little weaker, your body's clock would tick ever so slightly faster than one at sea level. If you went deep into a mine, the opposite would happen. Your time would slow compared to the mountaintops. These changes are unimaginably small, but they are there, stitched into your every moment. Your blood flows in response to your heart's rhythm. Your breath responds to the needs of your cells. And both are responding, in turn, to a space-time that changes with speed and gravity. Even in perfect stillness, you are part of a dance you cannot see. Think of astronauts aboard the International Space Station. They live in microgravity, moving around Earth at over 27,000 kilometers per hour. Their speed makes their time run slightly slower than ours. Yet their distance from Earth's mass makes it run slightly faster. The two effects nearly cancel, but not entirely. When they return home, the difference in their body's time is real, a few fractions of a second younger than those who stayed behind. What is fascinating is that this is not just a cosmic curiosity. It is a lived truth. Your sense of self, your memories, your aging, your feeling of now, is tied to a clock that is unique to you. It is not the same as your neighbors, your friends, or anyone else's, because no two paths through space-time are exactly alike. You are, in every sense, a living clock. A clock that walks and laughs and wonders. A clock that feels joy and sorrow. A clock that will never tick again in exactly the same way it has in this moment. Even as you read these words, your personal time is diverging from mine. It is not enough to notice, but enough to mean something. Enough to remind you that you are a traveler, even when you think you are still. Perhaps the deepest mystery is that we cannot step outside of this to see the whole picture. We are always inside our own time, looking out at others. We never truly feel our own dilation, only its reflection in someone else's story. If you could hold your own future in your hands, you might see the gentle warp of time folding across it. You might see how moments lengthen or shorten depending on the roads you take. You might choose your steps differently, or perhaps exactly the same, knowing that every choice bends the river just a little. You live in the present, but that present is not universal. It is yours alone, a private stream in the vast ocean of time. And though you share the world with billions of others, you will never share exactly the same rhythm with any of them. The atoms within you keep their silent beat. The cells within you mark their days. And all the while, space-time writes its quiet variations into their song. You close your eyes, feeling the pulse in your wrist, the breath in your chest. You are listening to your own clock. It does not tell you the whole story, but it tells you enough. And in that steady pulse, there is another question waiting. A question about how light itself, the messenger of the cosmos, carries the rhythm of every clock and the memory of every moment. Imagine drifting through space, far from stars, far from warmth. The darkness is not empty here. It is heavy, as though the air itself has weight. You see nothing at first, only the slow drift of faint starlight. And then, ahead of you, a region where light itself bends away. A black hole does not shine. It is the absence of escape. Its gravity is so fierce that not even light can outrun it. Around it lies an invisible boundary, the event horizon. Cross it, and nothing returns. You approach, slowly. From a distance, the black hole seems calm, almost still. Around it, a faint halo of light swirls, like water circling a drain too deep to see. Gas and dust spiral inward, glowing from the heat of their fall. But in the very center, silence. A darkness that is more than the absence of light. Here is where time begins to change its shape. Einstein's theory tells us that gravity bends not just space, but time as well. The stronger the pull of gravity, the more slowly time passes for someone inside it, compared to someone far away. And at the edge of a black hole, gravity is at its most extreme. You carry a clock with you, perhaps the one inside your own heartbeat. Tick, tick. To you, the rhythm feels unchanged. Seconds pass as they always have. Your thoughts unfold at their normal pace. Your breath, your pulse, your sense of self, all steady. But far away, an observer watches your approach. They see your seconds stretch. Your motion slows, not because you are moving differently, but because their time and yours no longer agree. Each moment you experience takes longer in their view. As you near the event horizon, their view stretches your last second into an eternity. From their perspective, you never quite cross over. You fade, you redden, you freeze. It is as if time itself has fallen asleep at the edge. Yet from your own perspective, nothing unusual happens at the crossing. You drift past the horizon without pause. The outside universe recedes from you, faster and faster, until it becomes a single point of light behind you. Inside, there is no turning back. This is one of the great paradoxes of relativity. Two truths existing together, each valid in its own frame of reference. From the outside, you never arrive. From the inside, you arrive without delay. The reason is space-time itself. Near a black hole, space is curved so steeply that all possible paths lead inward. Even the path light takes bends toward the center. And because time and space are inseparable, time's flow is pulled along with space's curve. Scientists call this gravitational time dilation, the stretching of time in a gravitational field. It is the same effect that makes clocks tick more slowly at sea level than on a mountaintop, but magnified beyond measure. Here, at the black hole's edge, the stretching becomes infinite. And there is something else, something the math tells us, but the senses cannot prepare for. Inside the event horizon, space and time trade places. The inward direction becomes as inevitable as the forward direction of time. It is not that you cannot turn around. It is that turning around is no longer a direction that exists. Just as you cannot choose to go from tomorrow back to yesterday, you cannot choose to go from deeper inside the black hole back toward its horizon. Your future now lies at the singularity, the point at the black hole's center where density becomes infinite, and the known laws of physics can no longer describe what happens. The singularity is not just a place. It is a moment in your personal timeline that you cannot avoid, just as none of us can avoid the moment of our own ending. And yet, here is the strangest part. From far away, that moment will never be seen. To the outside universe, you are still frozen at the horizon, forever approaching but never arriving. The black hole keeps your last visible moment like a photograph pinned against the fabric of space-time. This is why astronomers can take pictures of black holes at all, not of what's inside, but of the glowing matter just outside the horizon, captured before it slips away. In those images, the black hole itself is a perfect shadow. The edge we see is not a surface, but a threshold. You might wonder what it feels like to be so close to time's edge. If the black hole is massive enough, the kind formed from millions of suns, you might cross the horizon without feeling any sudden change. You might not even know you have passed it. Only later, as you near the singularity, would tidal forces begin to stretch you, slowly at first, then with unstoppable strength, in a process astronomers call spaghettification. The name sounds whimsical, but the reality is not. It is the stretching of your very being into a thin thread, pulled apart by differences in gravity from your head to your feet. In smaller black holes, this stretching happens before you even reach the horizon. The forces are so steep that they overwhelm you while the universe still watches. Black holes are not hungry in the way mouths are hungry. They do not seek or chase. They simply are regions of space-time where the slope inward is so steep that all roads lead down. If something falls in, it does not come back, not because it is destroyed at once, but because the rules no longer allow a return. To think of them this way is to see them not as monsters, but as places where time's flow is different beyond comprehension. They are the ultimate demonstration of relativity, where the gentle stretching of time we measure on Earth becomes an infinite gulf. Perhaps you are wondering, if nothing can escape, how can we learn about them at all? The answer lies in what happens just outside. Matter falling in collides, heats, glows, and in that glow, we read the black hole's presence. In gravitational waves, ripples in space-time itself, we hear the echo of two black holes merging. We learn not by seeing inside, but by listening to the edges. And at those edges, time is both moving and not moving. It is the slowest place in the universe from the outside, and yet perfectly normal from within. You float now, just beyond the horizon in your imagination. The outside stars have faded. The sky ahead is not a sky at all, but a direction that leads only inward. There is no turning back, and yet, there is no fear here, only the strange calm of inevitability. In your mind, you pause here. The clock you carry is still ticking, still steady, still yours. But you know that to the rest of the universe, you are frozen in this instant forever. And you wonder, if time can slow to a stop, can it also move at the same speed everywhere? If there is a universal clock, a single beat that all things share, where would we find it? Perhaps, you think, in the one constant the universe will never bend, the speed of light. You close your eyes, and the night opens like a quiet book. The world you know begins to fade at the edges, colors dissolving into a deep, warm dark. Somewhere above the quiet hum of your own breath, the stars are moving, slowly, delicately, as if they, too, are preparing for rest. You are not still, not ever. Even here, wrapped in blankets, you are sliding through space, carried by a planet that spins and drifts in the gentle currents of the cosmos. And as you move, time changes. It does not rush, and it does not truly stand still. It bends, it folds, it lets itself be shaped by the motion of your body, the pull of Earth's gravity, and the dance of celestial objects far beyond your sight. In the world of dreams, you may wander through hours in a single breath, or live a lifetime in a moment. This, too, is time dilation, not the strict mathematics of Einstein's equations, but the felt truth of time's stretch and shrink inside your own mind. Your body is a traveler even while it sleeps. Right now, the surface beneath you moves at hundreds of meters per second just from the Earth's rotation. Layer upon layer, your journey is bigger. Earth circling the sun gliding around the Milky Way, the galaxy itself flowing through a dark ocean of space. Each of these motions changes the way time trickles past you, though so slightly you'd never notice without a clock far away to compare against. If you could look from above, you'd see yourself in motion, not floating, but being carried in a spiral, a soft corkscrew path through the universe. This is the lullaby of relativity. The universe hums, and your seconds are never quite the same as those of someone far away. You dream of walking through a garden of slow stars. Each flower is a sun, and each petal is a moment in time. Some petals grow wide, catching the long light of stretched seconds. Others curl tight, pressed together, hiding quick and fleeting instants. As you pass, you brush your fingers across them, and they shift, time slowing here, quickening there. You realize the garden is not separate from you. You are both gardener and seed, the keeper and the kept. Somewhere, a clock ticks a little differently than yours. It might be on a satellite high above, where gravity is weaker and seconds flow faster. It might be on the moon, where the pull of mass is gentler and time runs just a fraction ahead. Or it might be near a massive planet, where the seconds are thick and slow, like honey dripping from a spoon. This is the strange kindness and cruelty of the cosmos. No one shares exactly the same now. In your dreams, you meet someone. They are standing in a field of drifting particles, golden motes floating in slow motion around them. You ask where they've been, and they smile softly. Ahead, they say, as though that were the simplest thing in the world. You realize they mean it literally. They have aged less than you, or perhaps more, depending on the path they took through the fabric of space-time. You walk together for a while, neither of you counting seconds, and you feel the odd comfort that in the universe's eyes, now, is not a single point, but a tapestry of moments woven in different directions. Back in the waking world, though still dreaming, your body keeps its own deep rhythm. Your heart, your breathing, the slow electrical waves of your sleeping brain, all are clocks in their own right. But each one ticks according to the path you take through gravity and motion. In this way, your very cells are touched by relativity, not in a grand, cosmic way, but in a quiet, personal way. Your heartbeat tonight is not quite the same as it would be if you were on Mars. Your dreams would not feel quite the same if you were circling a black hole. And yet, you never notice. You never need to. This is the gift of living at human speed. Time dilation on Earth is small, almost invisible. The difference is measured in billionths of a second. But the principle is always there, shaping the edges of reality. Even here, on this spinning, moving sphere, you are already participating in the great experiment of the universe. You imagine what it would feel like to step into a ship that could approach the speed of light. You picture yourself returning home after what felt like a year, only to find decades had passed. Friends older, cities changed, the sky rearranged. Would you feel cheated by the lost years? Or would you feel like a keeper of secrets, someone who has touched time's strange fabric and come back with the quiet knowledge that moments are not as fixed as they seem? The thought lingers, slow and warm in your mind. And then, you drift deeper. The sound of your breathing is like the ocean's tide, coming and going, each wave a small measure of time in itself. The earth turns beneath you, and you turn with it, your seconds sliding along a path you cannot see. The people you love, sleeping in their own corners of the world, are also traveling, their clocks keeping time in ways almost, but not exactly, like yours. It's a strange comfort, knowing that as you dream, you are gently moving toward someone else's tomorrow, and they, perhaps, are moving toward yours. The fabric between you is not empty. It is stitched with light and gravity, with the pull of massive bodies and the push of expanding space. In this web, you are both anchor and wanderer, holding your own place in time while drifting through someone else's. The stars above turn slowly in their arcs. The galaxies beyond lean forward in their eternal journey. And somewhere, at the edge of vision, the future waits, patient, unhurried, ready to arrive in its own way. You exhale, and the moment stretches. The night around you grows softer, quieter. Somewhere far away, another version of this second is unfolding. And as you sink further into sleep, you begin to wonder, if time can stretch between worlds, can it also stretch between dreams?